We're going to take the components you see here on the workbench, and we're going to build a 4-to-1 Balun matching transformer. We're going to take you through it step by step. It's going to be easy. You're going to want to build one of these for yourself, because here in the near future, we're going to have another video that's going to make use of this, and you're going to want one of these to take advantage of this new antenna. It's going to be a good one. Stick with us to the end. You're going to be glad you did. Okay, what we're going to be building is going to be a 2-core 4-to-1 Balun for use with balanced antennas, hence the name. We're matching balanced antennas to an unbalanced coax. So we're going to start assembling our core here. We're going to tape these 2 cores together, stack them up, tape them together, and then we'll start with our winding. Cut off a piece of tape here. And get it through, get it pulled tight. Wrapped around. And there we go. On one side, we'll do the same thing directly across. Got a little air bubble in there. Not going to be a problem. Get another section of tape here. All right. Get it pulled tight. Wrap through. And there we go. Now we've got them stacked together. Now we're going to need 3 pieces of wire. We can use any color. We've got multiple colors here. I'm going to use green, and I'm going to use white. The green one, we're going to need about 4 feet, because we got 2 cores. We'll measure out 4 feet using the grid here on our tabletop. And from there to there is 24 inches. We'll allow another 24 inches. And that's 24. Total of 48. Okay. We're going to wrap, this one will be one continuous wrap. And we'll start off, we'll bend out a few inches, do a 90-degree bend, then set this out of the way. I have enough trouble without getting things in my own way here. So we'll measure that up there, do another 90-degree bend, and then another 90-degree bend, another 90-degree bend there. Now, we should be able to take this, run the wire down through the center. And what we've done here, see how that is? Very nice. And we can start anywhere, but I'm just going to start here on this tape. The tape is not doing anything as far as insulation. That's not the purpose. The purpose is for just holding the cores together. All right, so we'll do 5 turns on this side. That's 2. Pull the wire through, pull it as tight as you can. We've got to leave some space in between these, and you'll see why in a few minutes. All right, there's 4. And then here's 5. All right, we've got 5 turns. We'll space those out a little bit. And then right here, on this side here, opposite, we want to do a little loop, just like that. All right, so you see we've got the loop here. Then we'll take this and go under, and then we'll wrap 5 turns going the other direction. All right, so there's 1, 2, and this is 16 gauge wire. You can use insulated wire like this. This is solid core, tinned copper. Okay, it's 16 gauge. This will handle several hundred watts. I would say up to 500 watts without any problem. This particular core combination with this wire should handle 500 watts sideband and 100 watts digital without an issue. Okay, let's see if we don't have 5 turns here now. So we got 1, 2, 3, 4, 5. Okay, so we do have our 5 turns, and we'll even those out a little bit. And we've got a little bit more wire than what we need. We probably could have gone with 42 inches. So we'll cut that off. I'm going to leave that one just a little bit longer for now. So 42 instead of 48. 42 inches. I'll go back and correct that at the beginning of this video so we don't waste a lot of wire. All right, so that's our first winding. Now we're going to do 2 other windings, and we'll use white wire for that. So we're going to need about 22 inches. And I'll measure that out here. There's 22. And we'll do that again. So now I've got 22, two pieces of 22 inch each. All right, we're going to wind these in between the wires that are already here. And that's the reason these are spaced out as they are. And we'll get them cleaned up, spaced more evenly as we go. And we'll do the same thing again here that we did with the first one. We'll do our 90-degree bends, like so. Then we'll run the wire through. So now we've got the wire run through. And what we'll do is we will just follow the other wire around. And this will go halfway. Just keep it up close to the green wire. Run it round. And this will only go halfway around, where the green wire goes all the way. That one didn't want to cooperate very well. All right. We should have 5 turns on that one. Okay. When we get through here, we'll put some zip ties on these to hold them in place, but while we're winding, we'll just do it this way. All right, so we've got 5 turns there. Now we'll do the same thing on this other side. Start out, do our 90-degree bend, measure to the top, do another 90-degree bend, then across the top, which is about a 1/2 inch, and down like that. So that's how the wire starts out. Put the wire down through the center, okay, like so. So now we follow that green wire back around. And the only thing is, you want to make sure you don't cross the wires up. You want to keep the same relationship all the way through here, where on this side, the white wire is always on the right-hand side of the green wire. And on the other side, the white wire was always on the left-hand side of the green wire. I'm just wrapping this one around, just like we did on the other side. And then we'll use a zip tie to secure them. And then we'll make our connections. So let me get a zip tie here, and then we'll finish up with our transformer. But that's basically the transformer there. The next thing is how we connect all these together. These two here go to your high impedance or your antenna. This is the high side, so this is the in our case, it's going to be around 200 ohms. And this side here is going to end up being your 50 ohm, but we have to connect these in a special way, which we'll get to in just a few minutes. Okay, got a few zip ties here, and try to get these through here, get these windings anchored down. Just so they won't be moving on us. Try to get this one. Okay, so that one's not going to move on us. Cut off that extra. All right, do the same thing on the other side here. All right. Okay. Let's see how we got that. Still got that loop there. We'll cut off this extra piece here. Get them out of the way. And this will be the antenna side, or the high impedance side, and this is your low impedance side down here going to your SO239. All right, let's we'll go ahead and put the Go ahead and put the zip tie on this as well, hold them in place. And get that through there. All right, that's got that one caught. And cut off the excess there. And do the same thing over here on this side. These things get a little fiddly for me sometimes. You want to make sure and catch both wires, and then we can cut off the excess. Okay, so we've got them both tied down now. Now what we want to do is match to this drawing here. This white wire here will go to the center conductor. This will go to the shield. And this green wire here will go to the center conductor. And this white wire here will go to the shield. So these will be stripped back and soldered together. And we'll strip these back here, and then we'll cut them to length when we put them into our box here. But these two here will be twisted together, and they will go to our center conductor, and then these two here will be twisted together, and they will go to our shield. So we'll go ahead and get those stripped and soldered. See how much length we're going to need here. We're not going to need a lot. This is our shield over here, center conductor here. The long green one, we'll remember, is going to our center conductor. Let's see how much we're going to need. Bend these up a little bit so we can fit this down into the case. See at 240/43, it takes up the majority of that case. So we're not going to need a lot of length on those at all. We'll leave about this much on this side. Make them approximately the same length. And about the same here. We're going to need, maybe about that much there. Put that back in here and look at it. Make sure we got enough. Yeah, we'll cut those off right there. And we'll, just for sake of keeping things straight, I'm going to put a little piece of tape on those. That's our center conductor. Just so we'll mark that. So those are our center conductor. And these will be going to our shield. And we'll put a ring terminal on this one once we get everything situated. Let's go ahead and strip the insulation off of those. About here. All right. Do the same thing with this one. fighting me. Now what we'll do, take this over here like this. We'll wrap that around a little bit. Get some needle nose here. And we'll just leave a little piece on there. And we'll put the ring, we'll solder this and we'll put the ring terminal on this. And then here's our center conductors. Tell you what I'm going to do. I'm going to go ahead and put the ring terminal on this to avoid any confusion. For these type of connections, I take the insulation off of the ring terminal because it's just in the way to me. You don't need the insulation for this type of connection, so I take it off. So we'll put this on here, get our crimping tool, and you see the split here on the top. You see that right there, my fingernail. You want to make sure that you put that into this recess. And that keeps it from spreading, and it allows it to crimp down on the wire better. So I've got the split at the top, I've got the blade at the bottom, as I call it. We'll put this on here and crimp it down. I wasn't liking the crimp out of that other crimper. This one works on the same principle. It's got the recess here and the tip on the bottom. I'm going to put it just like this and do the same thing and get a better crimp there. I like that better. That other one just wasn't doing it for me, so I swapped up, got this other crimper, little more heavy duty. I don't know if this is a brand name or not. It looks like there might be something stamped across there. I've had these for so long, but get you a good set of crimpers. We'll put some solder on this. We'll solder the ring terminal as well as the wires together. Make sure they've got good connection both sides. Put a little on the tip of the soldering iron so it'll conduct heat to the ring terminal, and you just let it flow in. You see how it flowed there? And we'll do the same thing here. Put a little there, make sure it's getting good connection. And we've got a good solder joint there too. Very good. So we've got it soldered together. This is going to be connected to our shield of the SO239 and coax. This one will be connected to our center conductor of the SO239. Let's go ahead and get those stripped back about to there. And the knife may not be the right tool for the job, but I've been doing it this way for so long. That's the only thing, that's the first thing I think of. If you've got a better tool, use it. There's more than one way to skin a cat. This is just what I've been doing. This insulation's on good. There it comes. All right. Now we got the green insulation off. We'll do the white insulation about the same distance there. There, that one came off a little easier. Now, you see the green, you're going to have your center conductor connected here, and it'll be going all the way around. See, the green doesn't come out on the antenna side. So you've got your center conductor going all the way around to your shield here. So the green here is connected to the shield here. So this is a true transformer. You got your positive and you got your negative. And then here, this white wire comes out here, and this white wire comes out here. So let's go ahead and twist these together. And we'll cut some of the length off of them, because I think we got more than plenty. May even have to trim it some more, but we'll go ahead and solder those together as well also. See how I touch the solder to the wire and it melts and flows? We got good connection there now. And we'll need to put some ring terminals on these also. So let's go ahead and strip those back a little bit. Now, like I said before, you don't have to use the insulated wire like this. You can use the magnet wire just like we have done on our other transformers. The primary reason I use the insulated wire is because it's color coded. You can see where it's going and what it's doing very easily. That's the only reason really why I use the insulated wire here. The magnet wire will work just as well. Get this mounted into our box, and then we'll put a resistor. We'll put a resistor across here, 200 equivalent of a 200 ohm resistor, and measure this with our NanoVNA to show you that it does step it down. I'm going to go ahead and get some ring terminals and crimp them on here. Then we'll connect those to the bolts here. Okay, got our ring terminals here now, and put it into the crimping tool like we talked about before, where the split goes into the half moon piece there, and put it on and crimp it down. All right, so that's a good connection already. Same thing here. And crimp it down. Now the reason these rings are bigger because these 1/4 inch bolts need to go through there, and that'll give us a good mechanical connection. We'll go ahead and solder these on as well, and then we'll be able to start assembling. All right. All right, got that one on. And got that one on. Let those cool for just a second, because they are definitely hot. Let's see if I can get some of this flux off of there. And now, back off these bolts. And let's see what we can do here. We'll put this one in first, since it should be cooler. And just pre-bend the wire a little bit. Do the same thing with this one over here. And see if that won't go in there. All right, got that one started. We'll get this one started. All right. And get those. Get these bent. And like I said, we may need to trim this one off a little bit more once we see what we're got to work with here. Yeah, I would say about another 1/4 inch at least there. And we'll put that into the center of the SO239. That looks good. Let's go ahead and put these bolts on finger tight at least to hold those in position while we're working on the other end of the transformer. All right, and all right, those wires went up into the end of the SO239, a fraction of an inch. So I'm going to go ahead and solder those in place. And then we'll connect our ground here in just a second. Get the tip hot. All right. Okay, that solder flowed into that joint really well. Let that cool just a second before we start moving it around and pulling on it and such. And I've got this top screw backed out a little bit. Go ahead and get the multi-screwdriver here and run it in some. Okay, now we can bend the ground or shield connection around, and we have the nut. These are 6/32 screws and nuts. They fit very well into the SO239. I use the 4-screw SO239. I know there is a 2-screw available out there. These are the ones I'm used to working with. Is one better than the other? I don't know. Probably not. Probably no difference whatsoever. All right. So now we've got our transformer. I'm going to straighten up some of these wires a little bit, pinch them together where they weren't exactly even with each other. Does it make a difference? Yeah, a little, not that much, but just for making it look good, making it work good, and I think we'll be good here. Not doing much, not being too rough with them, just straightening them out a little bit. All right, and that one there, looks like it needs straightening. All right, so there it is. See our little loop there. The green goes from the center conductor all the way around to the shield here. So that's one continuous loop. But the white from the shield goes and comes out here, and the white from the center conductor goes and comes out here. So this one would be hot, this one would be cold. And you might notice I got my holes a little bit too close to this boss here in the plastic. That could provide a way for water to get in, but once I get through, I'm going to seal this with silicone, and that silicone is not going to let anything through. In fact, this is the second time I've used this box. The box originally had a 140/43 core, and I wanted to upgrade it to two 240s. This will allow it to handle more power, but if you are not going to be running 100 watts digital, if you're going to be running QRP, I would wind it on a 140/43 and just use a single core. The winding would be the same. There's no difference in the windings whatsoever. The windings would be the same. The only difference would be the size of the core and how much power they can handle. Like I said, this one should be able to handle up to 500 watts sideband and 100 watts digital without any issues. So this is a, I would guess you'd call it a medium power transformer, but we're going to go ahead and get these nuts and bolts tightened down, and we'll connect our 200 ohm resistance across here and do our test with our NanoVNA. Okay, we've got our two 100 ohm resistors here connected in series. Got a little wire attached to it because this lead was a little bit short, so I lengthened it there, and we're reading 197.4 ohms. That's close enough to 200. We'll connect these resistors across our antenna connectors here, and we'll come back with our NanoVNA, and we'll test and see what kind of reading we get. Okay, we've got our NanoVNA set up in resistance mode. Got the scale on this from 0 on the bottom line to 100 ohms on the top line, the very top line up here. We have our resistors connected in series across the two antenna connectors here. This added up to 197 ohms as we measured earlier, and that's close enough to 200 ohms to do our test, because the antenna is not going to be exactly 200 ohms anyway. It's going to vary. So here we are at 3.827 megahertz right there, and we're reading, you can see the pointer right here, and the readout right here is 32.6 ohms. So let's go on up to 40 meters, and we read 40 meters at 7.235 megahertz, and we've got 44.8 ohms, getting a lot closer to 50 ohms there. This is what happens with every Balun, because the antenna is not going to be exactly 200 ohms, and it's going to react differently to different frequencies, but it gets it in the ballpark of 50 ohms where it's tunable with either an external tuner or if you have an internal ATU, either one will work. So here we are at 7.235 at 44.8 ohms. We'll go on up to 20 meter band. And 14.267 is what we normally use there. And we've got 52 ohms. So the 4-to-1 is working. We're getting a 4-to-1 ratio approximately across the bands here. Let's go on up to 17 meters. And there's 18.110 megahertz, and it's 54.7 ohms. All right, let's go on up to 15 at 21. And I believe we've been reading it at 21,300. And that's where we are now. And that's 56.9 ohms. Going up to 12 meters, 24 megahertz. And there's 24,997 megahertz. And we're reading 59.7 ohms. Still well within tunable range. We're going up to 10 meters. $28,332, and we're at 62.5 ohms. So the Balun is doing what it's supposed to do. It's stepping it down 4-to-1, approximately 200 ohms down to approximately 50 ohms. And if this, if this were 1,000 ohms, it would step it down to 250 and so forth. This is a 4-to-1 ratio. Whatever's here is 4 times higher than whatever's here. But since we're working in the 200 ohm range, this is stepping it down from 200 to 50 ohms. So that's how it works. In our upcoming video, we'll put this transformer to use. We're going to be building a interesting new antenna. I think you're going to like it. Be sure to subscribe below and turn on notifications so you won't miss it. But it's going to be out here in a week or so. And it's going to give a new price point for an antenna that you may be familiar with. We'll catch you on the next video. This is Kilo Mike 4, Zulu Kilo Bravo. Have a blessed day.